Hi, kids. I'm gonna do a little instruction video about why if something rolls without slipping, there is pretty much no heat that's gonna be generated. So let's talk about that. So first of all, let's review. So let's say I have something that's sliding along at a speed of v. Well, if I have something that's sliding along with the speed of v, that means that all parts of it are moving along with the speed of v. So I just drew 3 parts, but every single part would be sliding along with the speed of v. If there is friction, well, that means that this would be kinetic friction because it's sliding along. Okay, that is first semester stuff before rotation. Hopefully that makes sense. If you have something that is rolling without slipping, okay. First of all, we talked about this that in order to roll at all, there has to be that frictional force that causes it to roll. Without friction, it's not going to roll. But if you have something that's rolling without slipping, and I do the same thing, so let's say it's going to rotate around the axis right there, and it is going to move this way at the speed of v. Now, I need to do something here. I'm going to kind of regress, and then we'll come back to this. Let's pretend, okay, let's talk about a moving sidewalk at like a movie theater, okay? So if we talk about, or not a movie theater, I don't know what kind of movie theater I'm talking about, an airport, a moving sidewalk at an airport. Or I guess if you have a gigantic movie, I don't know. Anyway, moving sidewalk at an airport. So let's say that I have a moving sidewalk. Here's my moving sidewalk. And it is moving this way at the speed of v, okay? I have someone just chilling on the moving sidewalk. Well, if they are not moving along, that person would move this way with the speed of v, as long as you're not on the sidewalk. So, like, if you're watching the person go by, hey, look, that person's moving with the speed of v. Well, let's say we have a different person over here, and this person's in a hurry, so they are moving with the speed of v, and then the sidewalk is moving them with the speed of v. So, with respect to you, that person seems like they're going v plus v, 2v that way. Well, let's say that there's, some little kid on the moving sidewalk playing around, and that little kid is actually moving this way with the speed of v. He's running the opposite way. Well, with respect to you, okay, if you're not on the sidewalk, if you're looking at this kid, you'd go, well, wait a second. The sidewalk's moving this way at v. The kid's moving this way, the other way with the speed of v. It would look like that kid is not moving with respect to you. Okay? Does that make sense? The whole idea of this relative motion? That's important because if we go back to this, if this thing is rolling, well, that means, and it's rolling along with the speed of v, that means this top part is moving with the speed of v. Okay? That way. Well, this part right here would be moving with the speed of v that way. This part right here would be moving with the speed of v that way, and every other part along the edge would be moving with the speed of v. Okay. I'm not going to worry about these parts. It's a little more complicated, more than what we need to talk about, but I just want to make sure you understand it. Everything's moving at the speed of v around. Okay, so it's rolling without slipping. If you take a look here, well, the center is moving with the speed of v to the right with respect to a person not on it, or with respect to the ground. The top, though, would be moving with the speed of 2v, just like our person on the moving sidewalk moving with the sidewalk. So the top would be moving with the speed of 2v to the right, which also makes sense. If you rotate, that top is actually going to travel further, okay, than the middle would be. So it has to have a higher average speed. Now, remember, it's only traveling 2v the one instant it's right up here, and then when it rolls, well, then the next part that's up there is moving with the speed of 2v. But if it's over here with respect to the ground, it's no longer going 2v. And then this is the part that's pretty nuts. With respect to the ground, the bottom Because this is moving V, this is moving E, just like the kid moving the opposite way is not moving at all with respect to the ground. So remember, there has to be, so let's just say that the top is going 2V this way, the middle is going V this way, and then the bottom is not moving with respect to the ground. Okay. Remember, there has to be friction. Otherwise, it's not going to roll. It's going to just slide. And then if, with respect to the ground, it's not moving, that means this has to be static friction. Well, what does the word static mean? Oh yeah, the word static means not moving. Well, if something's not moving, how much heat's going to be produced? None. Okay, and which is why this force of friction is not going to do any work on this thing, which means essentially zero energy gets converted to heat. Now, if you want to try something just to show this, so you can see it and experience it, take something round, okay, and turn it on the side so it doesn't roll, and push it along the ground. That would be sliding friction. It's going to come to rest pretty quick. Have it roll along the ground, and it's going to roll a long, long time. Why? Because there's going to be hardly any energy converted to heat. Good? Bucket.